So I'm gonna be over here in my comfy chair with my fan blowing on my face. So what do we do when we have a problem like this? If we need to add these two fractions together, what do they need to have? What do we need to do?
They need the same thing.
They do. They need that same denominator.
I don't know this.
That's okay. It's on the bottom. I get why we would think that. It's valid. Point comes across. So what do we need to do? There's a hard way and an easy way.
Well, couldn't we just multiply the 8 over 2
Mhm.
plus,
There's one.
x plus 2 times 2 should be the same thing?
Yeah, because this, I could factor this right-hand one, and I could rewrite this as 3 over 2 times x plus 2. And we can notice that this has the x plus 2 in it, so the only thing it's missing is the 2. Excuse me. So I need to multiply this side by 2 over 2. Excuse me. Ugh. So by doing that, we can get ourselves to that same common denominator where we have our 2 times 8 on the top giving us 16. And our denominator we can write as our 2 times the x plus 2. Now that they have that same denominator, we can push them together. They have that same 2 times x plus 2. But our numerator now, what's up? I times the top and the bottom by 2. Just on the left one, because the right one already has the 2. This one, I factored this to get this. This was factoring. Factoring. Because we see in here that both 2x and 4 have a 2. And so we were hoping that when we factored that 2 out, it would make it so I didn't have to multiply by the 2x plus 4. And then also multiply this guy by x plus 2. Because that's the hard way to go, is if we multiply just by the denominator of the other one.
Well, and also if you do distribute the 2, it's the same.
Yep, if you distribute the 2, it comes back the same. So our numerator here is going to be 19. So whenever we've been working with these fractions before, we've always had to multiply by the funny looking 1 because we have not had an equal sign to go the same thing on both sides. So what we're going to do today when we're solving stuff is solving means we're trying to get to an x equals, therefore we're going to have an equal sign. So today we're going to start looking at solving these kinds of equations, and we're going to look at things in a couple of different ways. So we are going to be in your notes packet today. We're going to be on page 22, and we're going to start by figuring out some steps we're going to use to solve. So page 22 in your notes packet. What are we going to do? Page 22.
Good morning, Pike High School. At this time, AP African American Studies students need to go to room C106A. You will go to room C106A. AP Statistics students need to also be released at this time, and they will report to the fitness center going through the doors behind the East Gym. This afternoon, we will have AP World History students, and they will also go to the fitness room, go through the doors behind the East Gym. Thank you.
Maybe don't pick such a random room if people are getting lost. I mean, it's like the most random location I could think of in the building.
Why are they doing it in the fitness center? That's my question.
That is a very good question. I have no answers.
Like, they have gyms for a reason.
I don't think they need that much space for the gym, but why they're not using one of the many testing classrooms, I don't know.
We have testing class.
Like there's the language lab that's over by the lecture halls. Well, I don't know. I'm not in charge. I don't get to make those choices. It's used for testing a lot of times, and so I'm like, what? Why not this? I don't know. Okay, so let's take a look at our solving and our steps to do that. And what we're going to start with is the very first thing we're going to need to do. Yeah. Let me get your guys. Give me a second. Very first thing we're going to do every time is we are going to factor all denominators. Everything needs to factor. There we go. So we need to factor all denominators. And we need to find our least common denominator. So we're going to factor all of our denominators and find our LCD. Our second step is going to be to multiply every term.
Your U looks like an O.
Multiply. Or multiply. Like we're birds. Multiply every term by that least common denominator. Then we're going to need to simplify and solve. Meaning we want to get to an x equals. That's the goal. And our last step, step number 4, is going to be to check for extraneous solutions. And things will be extraneous if the denominator is 0. So if our denominator is 0 is when we have an extraneous solution. So we're going to factor all our denominators as much as possible. We're going to figure out what our least common denominator is. Multiply absolutely every piece by that least common denominator, and we can go from there.
Kind of looks like a 3-leaf flavor.
A little bit.
Yes.
Looks like it even has a little stand.
Nice. Do you want me to close the door?
If you could, that would be great. Or at least most weeks. I only have one person out.
What?
All right, let's look at this first one. Oh, just get it mostly closed. Just like, yeah. Because one person, I have one person out to the restroom. So let's take a look at this first one. We've got 6 over x equals 1 over 5x plus 1.
I thought you said what, not one.
That's 1. So, first step would be to factor all denominators. There is nothing we can factor here. I don't have any GCFs I can take out. I don't have any adding and subtracting. I don't have any squares. So there's really not much we can factor. Then we're going to try and find our least common denominator. Oh, page 21. Oh, sorry, page 22 is where it is. 21 is yesterday. Sassy pants and goo. There we go. Page 22. Fixed.
I guess I was staring at you on yesterday during D&D.
That happens.
I'll explain it later.
Okay. We need to try and find our least common denominator. What do they all have in common? Or what do they need to have in common? They all are going to need to have an x. So in our least common denominator, we need to make sure there is at least one x. That'll take care of this piece. And we'll take care of that piece. What else needs to be in the denominator? A 5. There's also a 5 in our denominator. So that'll take care of that piece. This guy has a denominator of 1, so we don't have to include anything special. So we just need one of each kind of set that's in the denominator. Because what we're going to do is we're going to take our 6 over x and multiply that times our least common denominator, that 5x. Then we're going to take our 1 over 5x and multiply that times our least common denominator, times 5x. Then we're going to take our plus 1 and multiply that times our least common denominator, 5x. So we multiply absolutely everything by that common denominator that we found. When we do that and come through here, look at each one of these individually. I've got 6 over x times 5x. What happens here with the x's? Remember when we multiply across, it looks kind of like that. What's going to happen with my x's?
Where?
They're not going to square. They're going to cancel. I have 1 on the top and 1 on the bottom. So we actually wind up with 6 times 5 over here, which is 30.
Over 1.
Over 1, technically, but you don't have to have an over 1. Same thing on our 1 times 5x over 5x. This time my x cancels out, and the 5 cancels out. So we're left with just a 1. And then we have our plus. And we have one more piece. Our 1 times 5x, I don't have anything that cancels out here. So we just get our 5x. What can we do to solve this to try and figure out where x is? Or what x is? Look at just this part. Ignore everything else. How do I get x by itself? Subtract 1. So we're going to have 29 equals 5x. Then what do? Do what with 5? Divide by 5 on both sides. I just could hear you. So we get 29 divided by 5. You can put that as a decimal as you want. We can leave it as a fraction. 5.8 sounds about right. Thank you.
That actually be
That's totally fine. That equals 5.8. So that gives us our solution. That's our solve. So what we need to do is we need to check that real quick. If we were to substitute in 5.8 here, is my denominator 0? No. If I substitute in 5.8 here, will my denominator be 0? No. Then it works. It checks. That is the only thing we need to do for the check. We need to make sure our denominator would not be 0. Bless you.
Thank you.
So we're factoring all of our pieces, finding our least common denominator, and multiplying so that we can solve. By multiplying every term by that least common denominator, we make it so there's no more fractions. Yeah, give me a second. All right, let's take a look at the next one. Very similar vibe.
Okay. Hey, that one has the same thing to walk me from the
Oh my goodness, what?
Whatever. I forgot what it's called.
Denominator.
Okay? And I meant the L word.
Yes, as the bulwark, the same denominator as the bulwark. So this guy has the same denominator as the bulwark. This one does not. So our very first step is supposed to be to factor everything as much as we can. So how does this guy factor? What can we do with that? It is a difference of squares. I know, it comes back to play. So this is where we take our square root of the first term, so the square root of x squared in the front. Square root of the 4 in the back, which is a 2. 1 gets a plus, 1 gets a minus. You can also do that with the fact that our a is 1, our c is -4. So we'd have a pair of numbers that multiplies to make -4 and adds to make 0, because I don't have a b. Gets you the same exact answer. So that becomes our denominator on the left, and our right, we already saw it in the bell work. I can factor out that greatest common factor.
The x plus 2's cancel out, right?
Nope, because we can't cancel across the equal sign. We have to factor everything and then find our least common denominator. So we're finding a denominator. It doesn't even have to be the least common denominator. It just has to be a common denominator that has everything. So we already see there's an x plus 2 in our denominator. We know that one. This guy already has that, so we're good to go there. We also need to include the 2. I'm just going to squeeze it in front. And we need to include the other piece down here, the x minus 2. Ooh, that pen is too chunky. So this has a lot of pieces here. Oh, thought I was against the wall. I have a little more space. So our least common denominator is this whole thing here. 2 times x plus 2 times x minus 2. That covers all of the pieces that are in the denominator down there. So what we're going to do is we need to multiply both of these sides, these 2 fractions we have, by the denominator. So I need to multiply this side by 2 times x plus 2 x minus 2. And I need to multiply this side by our 2x plus 2 x minus 2. By multiplying both sides like this, now we can get things to cancel. So we can only multiply both sides if we have an equal sign, otherwise we have to do the funky looking one. When we multiply both sides by this least common denominator, we can cancel pieces out. If we do this right, we should wind up with no fractions in the second part. Because on this left-hand side, our x plus 2 and our x minus 2 cancel out. So we're left with just 2 times 1, which is 2. And our right-hand side, our 2 cancels out, our x plus 2 cancels out, and we're left with 2 times x minus 2. What's up? That was going to be my next question, because we do want to get all the way to an x equals. I was just writing it down so that we had it here with all the pieces we had left over, because that was this guy and our leftover over here. Because then we need to find our solution. We want to get to an x equals. These were the guys that came down there. So yeah, our next step is going to be that we do need to distribute this. So we're going to take our 2 that equals 2 times x, which is 2x, and 2 times minus 2 gives us a minus 4. What do we do next? Add the what? Add the 4. Add 4 to both sides. We're going to get 6 equals 2x. So what does x equal? 3. So we got all the way down to our solution of x equals 3. Then we have to check it. We want to look and see. If I put 3 in here, 3 squared minus 4, is that going to equal 0?
No.
Nope. How about 2 times 3 plus 4? Would that equal 0? Nope. So this works just fine. It checks. Questions on this one? Okay, let's do the next one. Let's look at number 3. We've got 2 over x minus 2 equals 4 over x plus 1 plus 1. So what is going to be in our least common denominator? What pieces do we need to have?
X plus 1.
Yep, think of these as factors. So we're going to have our x plus 1. What else? And the x minus 2. So to do our solving here, our very first step means I need to take my least common denominator and multiply all the terms by it. So we're going to take our 2 over x minus 2 times our x plus 1, x minus 2. And that's going to be equal to our fraction that has 4 over x plus 1. And this also multiplies by x plus 1, x minus 2. And then we also have our plus 1 times x plus 1, x minus 2. So there's a lot of pieces in here. But we're going to come through and see what we can simplify. Because on this piece over here, my denominator is going to cancel out. So my x minus 2 cancels out over here. And we're left with our 2 times x plus 1. Then we'll look at our middle guy here. And here we have our x plus 1s that cancel out. And we're left with our 4 times x minus 2. And then our 1 times both those pieces, I don't have anything that cancels out. So we're just left with our x plus 1, x minus 2. And what do we need to do to try and be able to solve this thing? We should distribute a whole bunch of times. Bless you. We need to distribute here with my 2x and my 1. So 2x plus 2. Then we're going to have our 4 times our x minus 2. So we're going to have our 4x minus 8. And we're going to need to distribute over here too. So we're going to have our x times x squared, x times minus 2, minus 2x, plus 1x, minus 2. So many things. Can we combine some of these things together?
You can combine the -2x and the negative plus 1x, and then we can combine the -8 and -2.
We have a lot of x's here.
Oh wait, we can also add a 4.
And then we also have our constants here. So we need to be careful if we're crossing equal signs to combine them together, because we are going to want to get this set equal to 0. So we just need to be careful. And we know we're going to want it set equal to 0 because of this x squared here. So we're going to have our x squared. And then to get rid of this 2x over here, we've got a minus 2x from both sides. So what we have is 4x minus 2x plus 1x. So we wind up with a plus 1x. And for our constants, we need to subtract 2 from both sides. So we wind up with our minus 8 minus 2 minus 2, and we get minus 12. Those are really close together as far as rows go. Yes, dear. It's not over. It's just, I just placed it badly. I was just subtracting from both sides. So that it equals 0. Yeah, I was just subtracting the 2x from both sides. I just placed it badly. I'm moving it over there now. That's, so that was this guy, and this guy was just clarifying what those pieces were. So then if we want to get to an x equals, we've got a squared here. So what we're going to need to do, factor it, so we can get onto our solutions. Our a times c at the top, b goes at the bottom. Negative 12 at the top, 1 at the bottom. What pair of numbers is going to multiply to make negative 12 and add to make 1?
4 negative.
So we get our factored form of x with a positive 4 and x with that minus 3. So what are our solutions going to be? How do we figure out the solutions from there?
We take each of the factors and set it equal to 0.
Set each factor equal to 0. So our x plus 4 equals 0. And we're going to do our x minus 3 equals 0. So with x plus 4 equals 0, what is x going to equal? Negative 4. And how about for our x minus 3? Positive 3. We have two possible answers here, which is entirely possible. So we do need to check both of them. So what we're going to do is we're going to look and see. If my x is negative 4, will my denominator be 0 here? No, If x is negative 4, is my denominator 0 here? So this one works just fine. I'm going to make that green be a little bit darker. There we go. If x is 3, is my denominator 0? If my x is 3 here, is my denominator 0? So this one also checks. This one gets 2 answers. Okay. So we can have one answer. We can have more than one answer. We might need to do factoring a couple of times. We might not need to do factoring a couple of times. Let's look at the next page and look at the next one. We got time for at least one more. Let's look at number 4. And we're going to follow that same procedure. We need to factor everything so we can find our least common denominator. So looking at this guy, I see things that already look like factors. So think of this guy as a factor, this guy as a factor. So this is the only piece we actually need to do something to. So what we're going to do is we're going to take our 2x. What's up?
I didn't realize I put my pencil on my phone.
Ah. All good. How does this thing factor? X squared minus 9.
Difference of squares.
It is a difference of squares. Oh snap, we see those a lot now. Where we're going to have our x with our positive 3 and our x with our negative 3. That is using our difference of squares pattern. So everything else is factored. So what is our least common denominator going to be?
X plus 3 and x minus.
We have x plus 3, we have x minus 3. Those are the only things that exist in the denominator here. So our x plus 3, x minus 3 is our least common denominator. So I'm going to save myself a step and not do this in 2 different lines. And I'm going to do my multiplying right here. My x plus 3, x minus 3. Plus, we're going to take our fraction that had our 3 over x plus 3. And it's also going to multiply by that least common denominator. Oop. X plus 3, x minus 3. And that's going to equal our 1 over x minus 3 times x plus 3, x minus 3. So we multiply every single term by that common denominator. Then we get to come through and simplify pieces out. We have on this very left-hand side my x plus 3 canceling out with my x plus 3. And we have our x minus 3 canceling with our x minus 3. So this piece turns into just a 2x. On our next piece, the 3 over x plus 3 piece, my x plus 3's cancel out. And we're left with our 3, and the leftover piece was our x minus 3. And on the right-hand side, the x minus 3's cancel, and we're left with just our 1 times x plus 3. So we've got a little bit of distributing to do. We've got our 2x plus 3 times x gives us 3x. 3 times minus 3 gives us minus 9 equals our x plus 3. What do we need to do next? combine 2 and 3, we've got our 5x minus 9 equals x plus 3.
Subtract 3.
You can, but it'll give you more negative numbers. Get our x's on the same side first. Move the smallest x.
Add 9 and then subtract x.
Minus x from both sides. I'm just going to do it in 2 steps. We're going to have 4x minus 9 equals 3. And so then if we add that 9, can I do the view? Here we go. We get our 4x equals 12. So what is x going to be? 3. So looking up here, let's look at our check. If I substitute 3 in here, is my denominator going to be 0?
Yes.
Yes. If I sub 3 in here, would my denominator be 0? Yes. So this does not work. This fails the check. This is an extraneous answer. They made us do all this work, and it didn't work. It fails the check. And since it was the only option we had, we didn't have 2 like on the last one. This whole situation, this problem, has no solution. So we can have 1 answer, we can have 2 answers, we can have no answer.
What about 3 answers?
You can, but we're not going to see them in here. You can have polynomials with any answers, number of answers. Okay, so we have some steps to use. There is nothing wrong with number 5. It's a very similar vibe. We just don't have time because it's about to be, we're about a minute from the announcement reminder. Questions on this one? Okay. Because the only thing I have left for you today is the final homework. Do-do-do-do. Do-do-do-do-do. Do-do-do-do. The final homework. It's the last one. We are done with them. No more homework. After you do this one now. So it has 4 equations like we did today. And then 2 stories that we're going to work on tomorrow. We're going to do story prompts tomorrow, and that's our finish up.
When you're done passing it out, can you help me? Also, you gave us an extra one.
I'm so good at counting. Ow.
Isn't it 2000s that or something?
2000. Which kind of, is.
Oh, the bag.
So this varies directly with B, so they're going to be opposite, and it's inversely of C, so it's going to be on the same as C. So opposite side of B, same side as C. Let me get the announcements up, and then I'll show you.
I don't understand.
Oh, she got one.
It's a mush together.